Hey, Internet. My name is Bret. Welcome to the show. This is where we do a YouTube Live every week, and I have guests and friends where we talk about everything containers and Docker, Swarm, Kubernetes, DevOps, the cloud, all that stuff, all the buzzwords. I'm sure there's some that I left out there, CNCF, like KubeCon, you name it, like all that stuff. And so we have a lot of fun getting into the tech, talking about new projects, things that people are doing, interesting stuff, and taking your questions. So the cool thing about you being live, if you're watching this live, is that you get to ask questions of my guest, and we will sort of dive into whatever you want to talk about, focus on the topics we have today. So today we're talking about Ingress again, but this time we're talking about different projects. So with me on the show today, I need to have like an announcement sound. We have Steve Sloka from VMware. Welcome to the show.
Hey, thanks for having me, Bret.
So we talked briefly before the show about the history of you with VMware and how basically you have this history of your work with containers basically, and how you got involved with Docker. And one of the things I always love to talk to people about is how they originally found containers, how they originally got into Docker and all that stuff. So what's your story?
Sure, yeah. So before VMware and previously at Heptio, I worked at a very large healthcare organization. So a big 80,000 person enterprise, your typical, a ticket in 2 weeks to do anything. So to get a server, a ticket in 2 weeks, to get an application on the server, a ticket in 2 weeks, that sort of thing. So we found that this is early, 2015-ish, Docker just became kind of new. And we found that we could automate our applications, our development. So deploying Java, deploying our Angular apps at the time, Docker was, it was very easy to get the same versions everywhere, the same story that Docker sells. But the problem then was, hey, we solved our dev problem, but how do we solve this in production? How do we ship this?
Yeah.
Again, because it was, hey, IT person, go deploy this app for us and then troubleshoot it and that sort of thing. So the feedback loops were very long, and it made it hard for us to push changes. So we came up with, we thought, well, hey, how can we ship these Docker containers to production? And at the time, Kubernetes was just new. So we started using it in, I think, December of 2014, right after it became released as a beta. So we started shipping things off of that. And so from there, it just kind of blew up. So my role kind of moved from just normal software engineer to software engineer in Kubernetes and containers and that whole world as it kind of exploded around that time.
Yeah. And of course, now we look back, and Heptio was this rising star in the container and Kubernetes community, right? Some of the originals, Joe Beta, sort of this OG crew of people that were fanatical about Kubernetes. And then VMware bought them up 2 years ago or last year. When was that?
It was a little over a year ago, yeah.
Yeah.
So December, yeah. December of last year.
Yeah, and you've been lucky enough to focus a lot or exclusively on open source.
Yeah, so when I started at Heptio, we started working on open source, so the things we'll talk about today.
Yeah.
Contour and Gimbal. But so those were the projects that we started out at Heptio. And we were able to continue that through now the acquisition to VMware, and make those projects still be successful in the open source world.
Yeah. So, all right. So you're now a full-time maintainer of multiple open source projects. Like, what is that like? What is it like working on the internet with anonymous people every day?
Yeah. So so work from home. And I work I work on the team I work with here at for Contour is half of them are in Australia. So we have a different time zone metric as well, just because we're a few hours apart. So yeah, it's interesting. So you learn to work asynchronously. You learn to work through GitHub issues and that sort of thing. And then every now and again you have to chat, so you stay up late.
Right.
Someone gets up early.
I was gonna say there's no good time for those meetings. Yeah.
Right. Yeah.
Yeah, that's rough. But it's paying it off now. So obviously this is, we're in March of 2020. Coronavirus is on every news site, every conversation, everyone's talking about it. So for those of us we were just talking about before the show, like working from home has really been an advantage for us. Didn't really ever think of that as being an advantage of needing to hibernate at home. But now we were talking about that all of our friends are now learning how to be remote. And I'm just guessing that you are now like the office expert on the best microphones, the best webcams, like the whole office setup at home. Like you're the guru.
Yeah, you learn how to make that experience better, because being remote, yeah, this is my day to day is video chat. So
Yeah.
The less you can make that technology be a burden, then the better your conversation and your interactions are, I think.
Yeah. It's funny when you do this for a while, you take it for granted. You just assume that everybody knows all the right tech for their home office to make it pleasant for them and others, right? And because webcams still suck in laptops. Like laptop webcams are horrible. They're no better than they were 10 years ago. So it's nice to, it's nice to always have someone in the team that actually knows this stuff that can help everybody improve it. There's some great tweets out there. Like Scott Hanselman, I think, put one out at the beginning of the week that said, like, basically this is going to allow us remote workers to have more empathy and a better cohesion of our team because everyone's going to have what it's like to be remote and disconnected from the big office. And it's always tough when you're the solo remote worker and the rest of your team's all together in a big office. So, yeah. Cool. So, we're here to talk about Ingress again. So, bring everybody up to speed on Ingress, because if you weren't here on the show a couple weeks ago, when I launched a new part of my Kubernetes course, Kubernetes Mastery, and it was all about Ingress. We have yet to put in there anything about Contour and Envoy, but that is definitely on the to-do list to get more examples of Ingress, especially once we start getting in the course into operators and more of the CRD stuff where you're customizing on top of Kubernetes. So can you tell us a little bit about like maybe what the separation is between Envoy and Contour and how those are different than just like the Nginx one that everybody knows about? What's that all about?
Yeah, sure. Yeah. So Contour is an ingress controller for Kubernetes. So ingress in general, today there's a couple versions of that, but if we say ingress, we think about the V1 beta 1, so the Kubernetes V1 beta 1 API. So there's a contract there. So if you think of any generic ingress controller, it needs to implement that contract. So Contour does that, and its job is to watch the cluster, your Kubernetes cluster, for things like secrets, services, endpoints, all the information that it needs to go build that or fulfill that contract between your request and the backend pod. So in Contour's sense, it's getting its job. It does that. It sets up watches on the API in Kubernetes, and then pulls that information back, and then it builds a configuration, and then it passes that configuration down to Envoy. Envoy's job in Contour's world is to be the data path component. So all traffic actually routes through Envoy. In a technical sense, Contour is the configuration server for Envoy. So it implements Envoy's XDS protocol. And so when Envoy spins up, we give it enough information to go find Contour. Once it finds Contour, then we can pass that information down to Envoy, and then have it configured for all the routes and different things that it needs to do. And then when a request comes through, Envoy's job is to route that where it goes.
I'm going to get into that and show some examples. That's glad you prepared some of those. The ingresses that we all think about today, those are largely one cluster type of solutions, right? So eventually, once people get the hang of Kubernetes and they start to really love it and start to use it more, they end up with multiple clusters. There's really no shop that I've seen that's fully invested in Kubernetes that has just one cluster. And so there's becomes these challenges around how do you manage all these clusters. And I haven't learned a whole lot myself around these multi-cluster solutions other than just sort of general management. So is Gimbal has something to do with that multi-cluster thing. What's that all about?
Yeah, so Gimbal was another project that came out of Heptio. And so Gimbal's idea is to take Kubernetes and make it a software-based load balancer. So if you think of a load balancer, you want to have redundancy and uptime. So we can leverage Kubernetes to do that. So we can add capacity by adding nodes to that cluster. We can use the built-in HA capabilities of Kubernetes to make it redundant. But essentially what Gimbal does is it goes and allows you to send traffic to multiple different clusters. So today we support Kubernetes and OpenStack, and I have a PR I need to finish to send it to vSphere clusters. So you can have any number, again, of upstream clusters, and then traffic will hit this Gimbal cluster, and then it'll decide where that should go within the within those clusters. So now instead of thinking of if you apply the same idea of ingress to a single cluster, you can then apply this now to multiple clusters. So this solves the problems of what if a cluster needs to go down for maintenance, or you need to upgrade a cluster or something. You can now do that through this central software-based load balancer in a sense. So the only one thing I want to call out that we're looking at adding to Gimbal today is Gimbal requires having routable pod IPs, right? And this doesn't fit every customer situation. So when a request comes from Gimbal back to that backend cluster, every endpoint needs to be routable, which may or may not happen in every cluster today.
Right.
But we're looking at some things today to help solve that. But as the sprawl now, I think there was a trend to have large clusters in Kubernetes, and now the trend is to have lots of smaller clusters,
right?
For various reasons. So Gimbal can be a way to help you, send traffic across those different clusters.
Yeah, I definitely can agree with that trend because, when it was challenging, as the management of a cluster itself gets easier, it's easier to deploy, update, that stuff. Originally it was challenging enough to just get one set up. You didn't have all these cloud providers making one for you. And so, especially if you're going vanilla upstream, you didn't want to have to make a lot of them because there wasn't any tooling around managing multiple copies. It was hard to upgrade without breaking things. And as we get, I think, better at all that, I could certainly see how we're spreading out the number of clusters because we're comfortable, especially once the tooling supports, working with 10 clusters relatively as easy as working with one big cluster. And I know that a lot of the horror stories around upgrades in particular, trying to get the Kubernetes, all of the versions of things upgraded, that this idea of having multiple clusters and possibly even shifting from one cluster to another as an upgrade path is more sustainable. So, okay, so we have this sort of view of a proxy. There's a management engine on top of that for one cluster, and then there's this other management engine and proxy that surfaces across those. Is it kind of like the one cluster in front of many clusters? Is that kind of how this ends up laying out, where you have all these different layers of proxies all the way down?
Yeah, so for Gimbal, that's how it works. Yeah, so you have a routing cluster in a sense. So that's its own cluster that its job is just to be a router. And then you have your other upstream clusters that live around that.
Yeah, cool. And so since it's routing to pods, that's the problem you were saying with potentially if it's not using services on the back end clusters, it's using pods like a normal ingress would do, right? So that's, I guess, maybe the IPs maybe aren't routable between clusters. I could see how that would be a tricky. Well, I know you brought some demos, and we're on YouTube, so let's do some cool visualizations. I'm gonna turn it over to you on the screen share.
Nope, not that one.
And while you're setting that up, we have a question in. On Kubernetes, our IT guys still want K8s on Azure. Can we use Contour and Gimbal with Azure's K8 service? We then stop using Mirantis/Enterprise.
Yeah, for sure. Yeah, so Contour and Gimbal, its only requirement is Kubernetes. So however you get Kubernetes running, it'll work just fine. We've seen some things with other providers where there's different RBAC permissions that need to get set up sometimes. But generically, that's not a problem. To set up anywhere, it should work in any environment. Right. Cool. So is that cool?
Yeah, that's great. I said all right.
I guess I'm waiting for an answer, but you're not live on the. Yeah. So a quick I guess background of how Contour works. Again, we talked about the architecture of it. How Contour is the ingress controller and Envoy is the data path component. To dig into a little bit of IT speak of how Contour works, is you can think of Contour as a translation layer between Kubernetes and Envoy, right? So services in Kubernetes, secrets in Kubernetes, endpoints, all those different things get mapped through Contour into Envoy isms, I guess you could say. So again, this is Contour's job, is to help take these different objects and route them into here. One of the things we came up with at Heptio when we started out Contour and now VMware was this problem of ingress today. Let me go to a different slide. So Ingress v1 beta 1 has some things. So if I presented these ingress objects, right? So here's a bunch of YAML. I know this can be confusing, but essentially what these different ingress objects here demonstrate are there's two different teams, right? We have one team here in team A and one team here in team B. And what they have is they have the same domain name. This is projectcontour.io in this example, and /blog, right? So they both use the same host of the same path. but they target different services in Kubernetes. So they go to different places, and they're also different namespaces. So conceptually, to a team, this makes sense because you manage your own ingress resources. You're going to deal with this yourself. But when the ingress controller goes to process this, it's going to take a sum of all these objects and then smash them together and has to come up with one routing table out of this. So the problem here is that I've got two different domains with this, or the same domain with the same path for different services. So what happens here? And really, it's undefined. It's up to the ingress controller to define how this should happen. Does the last one in win? Does the first one in win? Do they both fail? And then you have a downtime in production. So this is kind of what we came up with. First off was this thing called ingress route. And then we switched it to this idea of, we had a new version of that called HTTP proxy. And the goal here is to support these multi-team clusters, right? Allowing a team or a set of people within a single cluster manage their own resources themselves. And we do this with this idea of delegation of routing. And here we can demo. I'm just going to skip through some slides because they're kind of boring.
By the way,
okay,
we have some. I was going to say we have a link to your KubeCon talk in the description. So if someone wants to watch the demo, the walkthrough, all that stuff, KubeCon North America last year. So yeah.
Okay, great. Yeah, so you'll see a lot of that in that talk as well. But here's the idea of this delegation idea, right? So what we want to solve is the problem of having multiple people be able to have conflicts with your ingress resources. So in this example, what I have is this what we call a root domain, right? So I have a root ingress resource, and it has this domain of project.contour.io. What I want to have is another team or this child resource own /blog, so this path/blog. And what it does is we have this idea of delegation. So if you think of DNS in the world, right? I have a DNS server, so I own stevesloka.com. If you create a server and say, hey, I'm going to serve records for stevesloka.com, nothing's going to break with my domain unless someone who has authority actually delegates, an A record or something off to you, to that server. And this kind of follows the same pattern. Nothing happens until the root, processes and include and gives this other resource the proper permissions to do what they want to do, or the proper inclusions. So in the same example we just showed, where we have the same domain with the same path, this person there's no conflict here, because Contour will throw this out, because it's not, there's no authority through this inclusion model. So hopefully that makes sense. So if you want, we can go and we can demo through this.
Yeah.
And see what it looks like. Okay.
And that's a good point to make, I think, around a lot of this stuff in Kubernetes, and like anything, I'd say just about every tool out there, a lot changes when you need a team to manage something. We all get started with these tools, especially container tools, and it's one person. And even some of the simplest tools, like one of the common things in my courses is that Docker machine tool that has been around for a long time to help you provision a simple little Docker machine. And people get used to that tool. They want to use it in a team, but that team was never scoped for that. So it has no authentication, no shared database of information. And in this case, obviously Ingress was designed for a team to use, but we don't realize how easily we can step on each other's toes with these DNS routes, right? These naming routes, until we do it. And then we're realizing, oh man, this is a problem. Like, I had a neat URL that worked for me, and then someone else came in and threw in their own route, and it suddenly is now taking precedence over mine. And not, people aren't used to necessarily studying every single existing ingress just so they can make a new rule. So it's a great problem you're talking about, because I have a feeling the way that people discover this problem is by doing it accidentally and breaking stuff. So. Mm-hmm.
Yeah, for sure. Cool. So what I have here is this is a generic ingress or HTTP proxy object. So this is our custom CRD. And if you're familiar with Ingress, we just showed it on a slide ago, but it looks very similar to how Ingress looks today. We have this virtual host spec here, and you define the fully qualified domain. Here I have some TLS certificates, so we're provisioning certificates through Let's Encrypt. And then here I have all my routes. Right. In this case, this is the super generic route where I'm just going to say, hey, everything goes to this one backend. This is called root app. So what we can do is we can take a look at get all the proxies in my cluster and show that I have just this one here. Let's go ahead and apply this again. We'll make sure that's clear. All right. So what I can do is if I hop over here to my URL, I can go ahead and query for this, right? And if I hit slash, I get the default app, right? Nothing too dramatic here. If I want, I can go here and add a second route. So here we're going to pull in a second set of routes here. Now let's talk about these conditions here for a second. So here I have these routes, right? So my condition here was slash, that was everything. Here I'm defining one called secure. So what happens on conditions here is conditions make up all of the things that need to be met for that path to route properly. So here we're showing just prefixes, but what we can do as well is we can pull in things like headers. So I could say, slash routes to this root app, but then slash secure, maybe must contain the user agent of Firefox. So maybe our secure site is only going to allow the Firefox browser. So if I go ahead and apply this one, what I have now is I have two routes. So I've got my slash and my slash secure. So if I hop over here to Chrome, my root one still works fine. If I hit slash secure here in my browser, you'll see I still get the default app site. I don't get the secure site. And that's because of those conditions, right? We're looking for the sum of the slash secure along with the sum of it has to contain Firefox. If I pull up my Firefox browser, which I have here, if I hop over to here, you see the default site works. If I hit slash secure, then I do now get the secure site, right? And that's because, again, we're meeting all of the criteria of having the path slash secure as well as this user agent. So this model kind of flows through. So I can have as many headers as I'd like, and we're left this open for other types of routing. So that's just the generic hello world. So right. I guess now what I want to do is go ahead and look at let's go add a team and let's do some delegation things real quick. So what we're gonna do is let's go create a marketing team. And this is my generic example. So I'll go ahead and create group control create -f marketing, and we'll do a one. So we'll create a namespace for our team, and then we'll go ahead and deploy a sample app for them. Okay, so I created a sample blog site. What I want to do is give them, again, that slash blog example that we did. So I'll create that, and I'll create one more thing. We'll create the proxy for them. All right, so now if I go ahead and bounce down a little bit, if I get my proxies again, what you'll see is I've got two of them, right? Because we had this root before, but now what I have is I have this marketing one, and you can see the status is orphaned, right? And that's because no one has a delegation path to them. So we haven't included that one yet into the mix. So this is the example of someone creating some sort of resource. Contour is seeing that and saying, hey, you don't have permissions quite yet. So what we can do is we can go and enable that. And we'll do that to this idea of include. It's this one here. So an include in Contour works like you would in a programming language. So if you had, say, C++, and you include a header file, when you go to compile that, the compiler is going to go inject that header file first into your code, and then compile the rest of the application. And that's kind of how these includes work. What Contour does is it looks for these includes, and then it adds them to the top of the ingress kind of tree, and then it then processes through. So here we go. So now this is our root here, and we're going to delegate off from to the blog site in the marketing namespace, which we just created. And here's the name. Blog site is the name, and namespace is marketing. And we're going to give them /blog. So if I go ahead and apply my root again, so now we just added that, and now we created the link. So if I go ahead and get my proxies, you'll see now that they're both valid, although I have a bad service here. Let's fix that up. But the orphan status went away. I think I have a bad demo here. So let's just go and fix that. So this is going to route to, yeah, see.
While you're doing that, I just thought I would remind people. So the reason that this is possible and that you're doing this in YAML is because instead of using the built-in Ingress resource that a lot of people, if they've taken my course, they would have been familiar with that concept because it's a built-in resource that just comes out of the box. But what you're doing here is you've added this a couple of custom resources types here, right? So that way, instead of having to do a bunch of annotations and putting all this stuff in just key values that aren't YAML formatted properly and all that, because you're extending this API of Kubernetes, you're getting this rich spec interface that is unique to the Envoy contour scenario, right? Isn't that how it's?
Right, absolutely, yeah. So yeah, the beauty of having these CRDs is we can, like you said, we can create our own types. So we're not the ingress spec today in Kubernetes isn't like broken. It's just limited. It doesn't have. It's not really well defined. So what we can do now is we can kind of define it more, and we can have it be richer for what we need to do. So there's a lot more here than we're actually showing. Like if you wanted to look at adding headers to requests, like request headers or response headers, managing the load balancing algorithm you apply to when these requests come through, all of that is in this CRD that we've defined. So you don't have to have any annotations across all of this stuff. The annotation sprawl can get really unwieldy if you use a lot of certain things.
We're all kind of used to configurations just spitting back that we did not do that right, and that's one of the challenges with annotations is that you basically have to do it, hope it's right, and then go check logs to see if there's anything complaining in the app, right? So, I think for some people that are new to this stuff, it's not as if we're extending the existing ingress features in Kubernetes. We're basically, in this case, we're just replacing them with a more feature-rich version that does exactly the same thing, only more. It's not really a disadvantage to it. It's an extra step you need to do on your cluster by adding in this custom resource definition. And we kind of all of the different CRDs you can look at out there, they always provide you all that information so that you know the command you need to apply to basically import it and change that stuff in your cluster. So it's not terribly complex to get set up.
Yeah, absolutely. And you get better type safety as well. So we can do some things like the status stuff that I'm doing. You can get better feedback from having these CRDs. But you have to buy into it. You've got to apply the CRD and use it and stuff. So for folks that maybe don't want to go down that road, or kind of you're tying yourself into this ingress controller by using this CRD unless other people adopt it. So people can use what they need down that road, because you don't want to. Some folks don't want to be tied into a specific provider because it limits what they can run against them, which is a totally fair.
Which is probably not an issue until you have 10,000 lines of ingress YAML, and then maybe you don't want to switch very easily. It's not going to be easy to switch providers.
Right. Yeah, for sure. Cool. So I think I got this fixed up. I'm not sure what was up, but cool. So now what we have two different proxies, and so the root now delegates permissions off, or the path /blog. I'll show that here. Here, this /blog gets delegated off to this marketing team, right? So if I look at the marketing team, what they actually go and create, this is all they have right now, right? So this is, again, namespace marketing. This is called blog site, and all they're defining is say, hey, I'm going to route to blog. And in theory, like, we don't have it here, but because we didn't define it, there's an inherent or an idea of the slash is there, right? If you don't define it, it just uses slash. So, but the result here, what's going to happen, again, like I said, it's an include. So it's like an include on a programming language. So what's going to happen here is this is going to end up being /blog is what gets passed here to the path, right? Because of that inclusion model. So if I go ahead back to my terminal here, or my browser, if I go to /blog, what I'll get now is I get the blog site, right? And that's that path. And what we're seeing is because we have that inclusion model, this team can then go and manage that path. They own that /path now, that /blog, and they can do whatever they want with it. They can make their own delegations. They can pass it off. So it's kind of a one-time setup of permissions, and then users can do what they want with it. Yeah. So the only cool thing I guess we could touch on too, I don't want to kill too much time, is there's the ability to have multiple services here in Contour as well. So with Ingress today, you can't have multiple upstreams. So you can do things now. I could have like service 2. I can route across many services, and I could even do weighting and things. So I could do weight of 80, and then weight of 20 or something, and do weight-based allocations across multiple upstreams, that sort of thing. And if you put your Gimbal hat back on, if you think of these as clusters and not different services, then you can weight-based routing across multiple clusters or that sort of thing. So again, some things that again the CRD lets you do. A lot of the stuff is coming in Ingress V2, which is called Service APIs. We probably should drop a link to that as well. I know we're heavily involved in that effort as well.
Oh yeah, that's cool. I definitely would like to update people on the progress, because I know that over the last year at the KubeCons, there's been discussions and a lot of stuff offline, obviously on this V2 that I've I talked a little bit about, I think, in the recent update to my courses, but I didn't have any hard evidence to show anybody other than here's a video from KubeCon a year ago that,
Yeah, for sure. Yeah, so it's definitely a thing. It's still some ways off, I think, from becoming ready to start using. But Contour actually has support for it, so we're going to start using Contour as a test bed. So once we start iterating through those different designs, you'll be able to actually play with them for real in Contour if folks want to do that.
Yeah.
So that'll be fun.
Do you so is there built-in support for Contour to use the built-in ingress if for some reason someone can't or doesn't want to use the HTTP proxy, the other custom, the ingress route stuff?
Yeah, absolutely. Yeah. So Contour is, supports all the same, the Ingress v1 Beta 1 API for sure. Yeah. So you can use that if you'd like. This is just another take on it. So Contour has multiple versions. So it processes v1 Beta 1 Ingress. It processes Ingress routes. This HTTP proxy we have now, and then also the new service APIs, which is the Ingress v2. And then Ingress v1 will come out here, and I think in Kube 119 is when it's going to get released. So we'll support that as well. So we kind of support all that stuff, yeah.
And with this, the wait option that you showed there, is that how you would do Canary, or is there something else?
Yeah. So here's how you could do. Yeah. So you could say, spin up your version, your new version, and give it 0%. And once you have it 0, then you could, swap these weights around. So maybe give it. These are just arbitrary numbers. These weights. So I usually make them add up to 100 just because in my head that makes sense. But you could do, like 77 and 5, if that makes sense to you. But yeah, so you could just flip the weights back and forth.
Okay, so it doesn't have to be 100, right? Yeah, it doesn't have to equal. Right. It's not percentage. Yeah.
Yeah, I can't do Y, but I could do like 8,005.
Yeah.
Yeah, and you can do that. Yeah, and you can swap it that way. You can also do some things where you, I know some folks like to do this with, like if you create a new app, you put it in a different namespace. And some folks will do like a blue-green deployment, right, where you just switch traffic all at once. And you can do that through like inclusion models sometimes. So maybe I have a marketing, new version or something, and then I can instantly swap from one namespace to another from the root, and then manage how traffic goes from A to B. So that's with inclusion, or you could do it just with the weights that we talked about here. You can swap weights.
And so you would do that by applying with a different namespace but the same name, so that it's basically updating the object in line. Is that how it's making sure that it's swapping the traffic there?
Yeah. So based on if I guess it was a new name, you would change that name as well.
Right.
As long as the name and the namespace match, then this stuff won't break.
Okay. Yeah.
Mm-hmm.
I was trying to imagine that workflow. So I know that there's other is there monitoring built into this, and do we have dashboards or anything like that to worry about, or is this focused on command line?
Yeah, so we do have Grafana dashboards that we support. So here I could give you a quick peek of that. So what I did here, I guess I did too quick. I port forwarded to my Grafana pod running in the cluster, and then what we can see here is now on the screen I have some different things. So I can look at. This is the Envoy dashboard. So this stuff here is showing you the open connections. So we actually have a new thing called a shutdown manager we added to Envoy. And this helps you roll out a change to Envoy. So if you had to roll out a new version of Envoy or reallocate resources in your cluster, what you don't want to have is as traffic's coming to your cluster, you don't want to drop connections. So what this does is it lets you shut down cleanly by waiting for connections to drain out. So this is the way to visualize what are open. Obviously, there's nothing in my cluster right now. But yeah, you can see all of the different Envoy connections in terms of the 200 responses, 300s, that sort of thing. We have some metrics on our proxy resources, like how many are existing, how many updates Contour is doing to the different Envoy listeners, clusters, and route services. I believe there was some metrics as well we had. Here's some API server stats. So how many, and we found some things where we have really busy clusters in Kubernetes, and that can cause some issues with Contour because it's got to churn through lots of different objects. So
right.
Just to visualize some of those things, we've added some stats here to help visualize how busy your cluster is, to help debug some of that sort of stuff.
Right, in case you don't have those metrics somewhere else already. Yeah. I mean, the thing you mentioned about service training, I feel like we could do a whole podcast on that.
Yeah.
I talk about it a lot when I start talking about day two operations because there's a lot of talk about out there around how to properly update services and other types of resources, and we talk about backups and we talk about maintenance and all that sort of stuff, rolling upgrades, all that stuff. But when it starts to get into application getting replaced by another application, and that you need to be so nuanced and so detailed in exactly how your app is shutting down and how it's monitoring connections and how so many apps like Python and Node.js don't track those by default. So you can't just necessarily depend on your app to not just terminate every single upload that's currently happening to your web app just because you decide to replace the service. And one of the experiences I tend to have, because I tend to work with a lot of companies that are migrating to containers, so they're coming from a legacy infrastructure where maybe they're only doing maintenance-based updates once a month, and they have this window and everybody knows. And now they're thinking that because they're in containers and orchestration, they can start rolling out these things really fast because their pipeline enables them to do so. And then they get into hot water because they realize, oh, we didn't really account for shutting down all our connections, and now we have people that are clients that are complaining around our maintenance time. But I thought we weren't supposed to have a maintenance time anymore.
Right.
And so I feel like having more visibility into that is such a huge thing. And I'm glad you mentioned that because for those of you watching, cannot be understated. Please test a lot during your rolling updates, whether you're going to do rolling updates, blue, greens, canary, whatever. Make sure you're doing all the things that users would be doing on your platform, especially if they're doing things like uploading or downloading large things, because I think that's what really gets companies into trouble. When it's a static website, no one notices because you just hit refresh and the thing's back up. But there's so much subtlety to those connection shutdowns that I think a lot of people glaze over that, thinking that the load balancer is going to somehow magically protect them from it. So,
And it may take minutes or hours to do that too. Like it may take you 6 hours to roll out your change because you're waiting for connections to drop and that sort of thing. So,
and you're just sitting there going, "Come on, people, close your browser.
Just go away.
I want this new version finished so I can go home." Yeah, because usually if you're the operator that day, you're not going home until till all the connections are gone, and so maybe don't have these 6-hour wait states in your HTTP connections where you're just you're polling after 6 hours. Like, maybe don't do that. Maybe have them 30 minutes, 20 minutes. That way you can actually have these short deployments, because these deployments can get these updates in particular can get really long if you have these long connections and WebSockets and stuff like that. Well, I kind of threw you that curveball with the visualization, and I didn't realize that you were going to have all that stuff ready to go. So what else you got? You got anything else in there that you haven't shown off?
I don't think so yet. I think that anything else would be a whole nother, like you said, whole nother
conversation.
Podcast, the chat. Yeah. I think Contour is what makes it unique is we're very open. We're actually looking at getting it donated to the CNCF soon. So again, we've been 100% open source since the start, and so appreciate your feedback. The other thing about Contour I think we probably should chat about is just it's opinionated in the sense that we like to have good defaults for things. So you might look at like having like a request timeout or something and make it like have lots of knobs in the application. And what we found is that users can get into a bad position by having too many knobs and not understanding how those work. So we try to not add lots of knobs and let Contour kind of set same defaults. Like we won't allow HTTP 1.0 requests unless you really, really want that. Things like that, we talked about those annotations, right? There's a common one that says, when I get a request to a plain HTTP endpoint, redirect to a secure, HTTPS website. But in Contour, when you specify a certificate on a domain name or a vhost, we'll automatically do that for you because we assume you're going to want that, right? So why annotate all of your objects and maybe miss one and not have that redirect?
Yeah, or learn the hard way.
It tries to do things like that make sense in the world that you're going to want this, so let's just do that for you.
Yeah, and
but again,
I like that. I mean, being a Docker person, I'm a big fan of opinionated, easy defaults. As long as we all have the documentation and everybody knows how to change them. But I think a lot of us are just already overwhelmed by all this tech. Like, none of us were doing this stuff 5 years ago. Like, this is all new stuff, and it's always overwhelming for people to add these new layers of tech to their stack. And keeping the YAML short and keeping the defaults sane is, I think, always a good thing. And having, what is it Docker used to say, batteries included but swappable. I think is what they
Yeah.
used to call it. I always like that term. So very cool. So how can people get involved? So I've got over here on my screen, we got the Project Contour website. So that's kind of the homepage for it. I'm sure that there's all these great getting started guides for adding the CRDs to your cluster. You talked a little bit about the operators, though, and how exactly, for those that aren't familiar with necessarily how these operators and CRDs and all these things play into part here, because we haven't had a great discussion on this show about operators. What's the difference between adding the CRD so that you have this ingress route and HTTP proxy resource and the operator? What's the difference there?
So I think sometimes operators are an overloaded term
For
today.
sure.
So generically, what Contour is, it's a controller, right? So that it's a controller that's watching for a set of resources and then taking action on them. When I think of an operator, I think of it having production knowledge about deploying new things. So like a few years ago, I helped initiate the first Elasticsearch operator, which we chatted a little bit about before. So its job was to have CRDs, but then create new resources based on what you defined in those YAML. And what it did was it was able to look at the cluster and take action. So again, it's opinionated that it's going to help manage, a complex application, so a database or something like that, which has more operational knowledge around it. But generically, yeah, controllers are but they're exactly the same thing, right? They still have these watch loops and these control loops that you're implementing. It's just more of, in my head, how is it applying that to a cluster?
Okay.
So
go ahead.
Yeah,
Sorry.
just having CRDs themselves doesn't mean you have an operator, I don't think.
Right.
You can still have, like Contour has CRDs, but I wouldn't call it an operator.
Okay. Yeah, because when you get all the fanciness out of the way and we try to define the operator framework and we talk about operator hub and all these things, the simplest way I've been able to come up with it, and I'm probably wrong in some cases on this, but a CRD to me tends to mean that you're using the standard kube control command line to apply YAML, and you're just using a different type of resource. So your YAML kind, the little thing at the top that says kind, is different, and then you get this different spec. But once it becomes an operator, in my experience, it tends to be an extra optional command line, whether it's an addition to the kube control command line, or maybe it exposes itself in a web portal, or maybe some third-party additional tooling. But it seems to abstract away a lot of that automation and intelligence that you yourself no longer have to know into something else. Would you agree with that?
I think so. Just sometimes that sounds scary to let somebody else manage all of that for you.
Yeah.
But I think it's coming better. I think in the early days they were new. I think it's getting better. But yeah, I would agree. I think to me it's a complex app that it's getting managed, itself sort of.
Right. Yeah, I think some of the best ones I've seen are where, the setup of a 3-node database cluster without you having to perfect your YAML and then hack through scripts this legacy database thing that doesn't know how to be automatically set up because it was designed way before containers were ever invented. And those to me are some of the big bang for the bucks on keeping you out of the weeds of the nuance of how a MongoDB replica set is set up, or how a mirror is set up on MySQL or stuff like that. But as we're maturing in this world of CRDs and operators, it's interesting to see some of these new ideas about what an operator might do, and sort of the grudge work of the day-to-day, how do I do a backup of this server and make sure that backup's constantly being done, and make sure that if it doesn't back up, I don't have to set up all these extra systems just to do a simple backup and be notified if it failed, right? So that's really the kind of exciting stuff I'm seeing there. So when we get to the Gimbal, is the Gimbal experience a whole lot different, or is it sort of I'm assuming it's a different CRD, right? So we've got a different resource kind in there?
No, so it uses the same HTTP proxy resource that we just demoed. So really what Gimbal does is actually we didn't explain this. What it does is it goes and replicates all the services and endpoints in each upstream cluster. So it'll take every namespace. So say you have a marketing namespace. It'll take all the endpoints in that one and copy it to the marketing namespace of your Gimbal routing cluster. So now you have a copy of all those services and endpoints. So essentially we're using Kubernetes as our own data store, right? We don't have to have our own database or something. We're just using etcd
Right.
to do that. So once we have all those in the Gimbal cluster, now you can just create your proxy resources in that Gimbal routing cluster, and then those same endpoints show up there. So as you change applications on the backend clusters, Gimbal will automatically synchronize all of the different services and endpoints to make them show up in that routing cluster. So you would define all of your Ingress resources in that routing cluster, not in the upstream
Okay.
cluster.
Okay, so it's not a bunch of repetitive commands.
Right. Yeah. So it should all just as soon as you turn it on, it should all the stuff should just show up automatically.
Right.
And you just define your routes that way, and then you're off to the races. And you have the same different inclusion model. So you apply all of that. Now you can have lots of teams be self-sufficient, and you can also bridge other worlds. So like if you had, in this case, OpenStack or something that's not containerized, where you have different endpoints living out somewhere else. Like I said, I have a vSphere discoverer that I have to go merge yet. So if you have a bunch of VMs that may never, be containerized, you can still bridge those worlds together from Kubernetes to these, VMs and traditional infrastructure, and still have a way to route to everything.
Yeah. All right. We've got some questions in chat. Let's see. Can you contrast to traffic plus minus? I use that for my local development work with Swarm, and it's very lightweight, almost exactly the same laptop experience as production, enterprise layer 7, yada yada. Okay, so I don't know how much Steve knows traffic, and I don't know Contour, so okay, let me just talk. I said off the top of the head. So Contour, is there any Let's Encrypt functionality in there?
Yeah, so if you can do the same Ingress annotations or create the cert, the Ingress manager or the cert manager CRD, and Contour will process that the same. Yeah, so it'll work out of the box.
Okay. Okay, so if I wanted to do Let's Encrypt, it will allow me to it'll respond to requests for me, right, from the verification.
Right. Yes.
Yeah, and then okay, so it would use Cert Manager for storage. In that case, that was actually a question. Is that what you were saying?
Well, storage for what? For the
sorry, for the certificates. Yeah.
Yeah. Well, they'll get written to. I guess saying there's two ways you can get certs. You can annotate it with an Ingress object and say, hey, go get me a cert that way.
Yeah.
Or you can create a cert manager CRD object type and say, hey, I want a cert with these parameters, and then cert manager will process that the same way, which eliminates having to have that Ingress resource.
Okay.
Around.
And then if you want, the next thing I'm thinking is if you want fault tolerance in Contour, what does that look like? Like, is it multiple Contour controllers?
Yeah, so you can scale it out as much as you'd like. So if you need more network, I'm losing words now. More network capacity, you add more envoys to your fleet.
Sure.
And then you can have as many contours as you'd like as well. So each contour will respond. Like I said, Envoy connects to Contour for its configuration. You can have as many as you'd like. The only thing that Contour has is a leader election that happens to figure out who can write back status. So only one person should be able to write status to the API.
Oh, okay.
So that's the only lead election bit in there, but everything else, every Contour is an active member to fulfill requests from Envoy.
Okay. And are these separate pods, the Envoy and the Contour?
Yeah, so by default, we deploy Contour as a deployment, and we deploy Envoy as a daemon set.
Okay.
So you get one per node. Envoy kind of scales with CPUs and disk I/O, so it doesn't help to put multiple envoys on a machine. You don't gain a lot from that. So by using a daemon set, we can just have one per node. But again, it's up to you. There's no requirement around that. You could have them all. We used to actually deploy Contour and Envoy in the same pod when we first started, and deployed those all over the place. So it's really whatever fits your network. So it'll work in any different model.
So now you're scaling back on the number of contours. So it almost sounds to me like your Envoy scaling is based around your load of client connections, and maybe your contour scaling is in terms of scaling for throughput or whatever. It's scaling more on just the change rate and whether or not you want fault tolerance. Is that?
Yeah, you'd want multiple contours. So if you lost a single contour, then you'd want all the envoys to connect to a different instance of contour, so it wouldn't lose configuration. The contour works kind of like Kubernetes. Like if the API server goes down, everything should work as is.
Right.
In the last state that it knew about. But yeah, so you'd want to have multiple contours to have that fault tolerance that way. Yeah.
But it doesn't actually need to scale. Like, in other words, if you're suddenly getting millions of hits, it's not like contour needs to scale. It's the envoy that's really doing all that work, right? Because we're really just talking about the controller acting on changes in the API. So if you're not doing a lot of API changes, then maybe you can get away with just two contours. I'm curious, for that leader election, is that doing Raft something, or is that something different?
I think we're using the config map set up in Kubernetes. So there's a client Go example that everything uses. So it uses a config map to write to, and whoever can write to that defines who it is.
Okay.
So it's a built-in thing in Kubernetes, yeah.
Yeah, that'll work. And that's nice because then you don't have to have at least 3.
Right, yeah. You could have 2 and it would still work, yeah.
Yeah. All right, let me see if there's any other questions here. Running the complete Kubernetes contour Gimbal stack on a laptop so developer experience is the same as production. Is this practical or just heavy? Biker, my opinion is that's heavy. If you have to have Kubernetes to develop, you might be doing it wrong. But Steve, what do you think?
So yeah, I go back and forth on some of that, depending on how much stuff you've got running. There's actually on the Project Contour.io website, there's a blog post I wrote how to use Kind. So Kind is Kubernetes and Docker, so it's a way to spin up Kubernetes with just the Docker client. So it's a neat way to get quick clusters. So I show you you can do that easily on your machine. So if you want to deploy Contour or traffic or whatever ingress controller you'd like, you should be able to swap in and out Contour for that. Yeah, so I guess it depends on you. Whatever makes sense for you. We used to run a lot of stuff locally, and then at some point it got heavy and we deployed out to shared infrastructure. But then there's pain in that because when it breaks, you can't just destroy it as easily. Yeah. Whereas locally, you could just throw the whole thing away and start it again real easily.
Yeah.
So I guess whatever works for you depends question or depends answer.
It does. I, for one, know no one that wants to develop in Kubernetes. There are some people that maybe think they have to, or they're told to, but oh my goodness, like, who needs another tool that's going to slow their CPU and eat their battery?
Right.
And the reality is that Kubernetes was never designed to do that. Like none of the original scope of it was designed to be a development platform on your local machine. I know there's lots of tools that do it. We got Scaffold and all these other things that are trying to make it easier for people, but just because it can doesn't mean it should. So like if you hear me rant about it a little bit, I'll just say, hey, look, what's wrong with Docker Compose? Like that keeps this minimal. Or increasingly, the shops that I work with, they're unless they're maybe like a Ruby shop or maybe some shops where they just don't have an easy way to manage the state of their local app development. So if they're switching between different apps and they're constantly have to worry about like Ruby versions and version management and stuff like that is a thing. What I've been finding though lately is a lot of shops I'm working with, they really are focused on developer happiness, and those developers are not happy if they have to develop in a container all day. So even though they are using containers, what they are using them for is only for spinning up all the backend services that'll run on like localhost and Docker Desktop or something. And that can be on Kubernetes or on Compose or on Swarm or whatever you want. And then it just let them be on their native OS because their apps are designed for that, and all their advanced tooling and everything is happier that way. I keep thinking that we're going to get to a way where we have this sort of sweet spot where all of these, all of the dependency injectors and all that stuff will all be container friendly for local development. But there's a reason I put out an entire Node.js course on this, because it is not easy and it's not intuitive. Right. And Node.js is one of the good ones. It's a little easier than a lot of the other ones. So I don't know. I go back and forth. So yeah.
I know a few years ago I wrote a tool. And what it was to help we had the same problem where we had like QA folks and stuff that didn't have all the tooling to actually compile the code. So we wrote a tool that would actually deploy feature branches to namespaces in Kubernetes. I think someone else has done this now. Yeah. But at the time, I thought it was cool by coming up with that. But so then you'd get a unique URL to that branch, and then it could QA that branch, feature branch, test it, validate it, and then ship it that way. So then the whole thing would tear down when the branch went away. So yeah, that's another flip on developing in Kubernetes, where you're not actually compiling code on there, but you're able to test different features and stuff.
Yeah, no,
using flexibility.
I'm definitely a fan of that. Is that currently an active tool?
No, it's one of those things that I built and then nothing else happened to it. So
right,
yeah,
right. Because I mean, that is a common thing that I think a lot of people are asking about is that they want, whether it's feature branches or every PR or stuff like that. We've got some of these tools now, some of the CI tools, and even some of like the static front end tools like Netlify and other ones. They're all out of the box trying to automatically make every PR you're doing in every branch, if you wanted to just make those sites and publish them, so that you have all those URLs. And I think I wouldn't be surprised if that becomes a standard, is that we spin up these mini environments, whether it's in kind or in a different namespace of a single test cluster or whatever. As much as we want to automate all these tools, people love still having a URL, to look at or to test or to give to somebody else if they're not running all the same stuff locally. So that's cool. What else we got here? Some opinions about this in chat. Got lots of good opinions. And I think that's it for the questions. I think it's all just good comments about the pros and cons of all this stuff, of complex local development or simple development, and just saying, hey, look, it's hopefully CI is going to work it out. If we have any cross architecture problems, hopefully CI will help us. Maybe just running the local tests. I think I'm also a fan of doing it as much as possible so that all your CI tests can also be run locally instead of having to wait on a CI solution to go through those pipelines. So I tend to use Docker Compose for that heavily. Are you primarily now? Is a Contour in Go? I can't remember.
Yeah, it's all Golang. Yeah.
Yeah. So you're spending your days in Go?
Yes. Yeah.
And so this is probably a conversation we should have had early on. What does your local development environment look like? I'm assuming you're Go native on your machine.
Yeah, so I keep flipping back and forth between Linux and a Mac. I just got a fancy new Mac from work, so I'm back on the Apple train.
Is it the new keyboard? Do you have the fixed keyboard?
Yeah, it's the 16-inch.
Nice.
Yeah, you can type again. Yeah. But again, the same. So I'm Go natively. I use Goland. I was a VS Code user for a while for Go, but I find Goland has lots of little things that I've come to rely on and enjoy. So I use that, and then I use Kind for clusters and stuff. But I still miss having that Docker instance run as a VM. Still is heavy. So nothing like having Linux to do all that.
Yeah, they not too distracted, but for those of you still watching, I will be putting out some information. Docker actually published their very first roadmap here in 2020. And so now they have this open source roadmap for all their tooling on GitHub, and you too can request new features of their tooling. And several of those are around shrinking the binaries, getting a lot of the tooling out of there that was maybe now legacy or unnecessary or has been replaced by something else, and the team's looking to optimize a lot of that. Especially now, we're kind of hoping that they'll take their Kubernetes instance inside Docker Desktop and just go to K3s and have that, because that seems to be the most minimal in terms of my experience with CPU. That seems to be the easiest way, other than just Kind, in running Kubernetes without burning down your battery in a couple of hours. So we're kind of hoping that it'll get better for that. But if you're on Linux, and you ain't got nothing to worry about.
Right, it's all there.
Cool. Well, Steve, thanks so much for being on the show. We have some people talking in chat, but nobody has asked any further questions, so we're going to wrap it up at our hour. Okay, so people should get involved by going to the GitHub repos, right? I think I pointed those out. There's the Project Contour repo. There's actually a whole organization for that, right? So we've got, we've got the Contour in here. We got Gimbal in here, so people can look at the stuff, download the stuff, file issues. You're probably gonna be involved with that somewhere. So be nice. Be nice to our open source friends out there, taking care of you by making all the free stuff.
Yep.
And we know your Twitter handle, so if you want to check him out on Twitter, he's there. Say hi to him on the Twitter, and that's about it. Where else can people find you on the internet?
I'm Steve Sloka pretty much everywhere. So
okay.
GitHub.com/Steve Sloka. Yeah. So
right.
It should be easy to find. Yeah.
Yeah. Cool. Well, thanks again for being on the show. I look forward to hearing. Unfortunately, I won't be seeing you in KubeCon in a couple of weeks, but I look forward to the updates of these projects and getting into them myself and learning a lot about them. And hopefully we'll have you back on the show with the next major release and a whole lot of new stuff. Maybe when we do Ingress V2, maybe when that comes out, we can see how Contour works with that. So
yeah, sounds good.
Yeah, thanks again. All right, everyone, we'll see you next week on this show. On Thursdays, I'm live almost every week, so come back here. Otherwise, also, this show is now supported on Patreon. I probably should have mentioned that earlier. So if you want to keep this show going and all the other free activities, free things I put out there, like the newsletter and the GitHubs and all that stuff, please help me on Patreon. All of your patronage is really greatly appreciated. So we will see you next week back here on YouTube Live.